The law of conservation of mass and energy is commonly called the law of conservation of matter. It basically states that matter can neither be created nor destroyed. Now that applies both to mass and also to energy. So you can neither create nor destroy mass, nor can you create or destroy energy. Therefore, matter is equivalent to mass plus energy. This is a very, very useful law in chemistry and applies directly to physical and chemical changes. This little diagram over here to this side shows you a before and after shot of a reaction that takes place. We can neither create nor destroy it, we can only change it. So just a little cartoon showing you that his mass before and after the explosion that took place, before and after he combined the two elements in his hands here, was exactly the same, 70 kilograms. Now this idea was developed by this man down here by the name of Antoine Lavoisier. Lavoisier was a French guy, and he worked in the city of Paris and developed all of his own lab equipment to actually measure the amount of something that was given off when a compound burns. And up until that point, everyone believed in this concept of phlogiston. And this phlogiston was this mystical air type of essence that contained heat and all the other things like that. And Lavoisier didn't really believe in that. What Lavoisier believed in was that something was being given off, and it had to be measurable. And so he actually created many of the different pieces of lab equipment that he used to capture this essence that was given off by burning substances. And that essence that he was actually catching wasn't phlogiston, it was gas. And as he measured the gas meticulously, he came to the conclusion that the mass of the products was exactly the same as the mass of the reactants. In this equation here, we have a couple different things going on. We have wood combining with oxygen in the air to form something new: ash, carbon dioxide gas, and water vapor gas. Everything on the left side of the arrow, the before the reaction, these are called reactants. Everything on the right side of the arrow, these are called products. And the equation that we use for the law of conservation is that the mass of the reactants must be equal to the mass of the products. The law of conservation dictates that we cannot create nor destroy matter, but it doesn't say that we can't change it. In fact, that is what's happening. When we take wood and we burn it in air, we are converting it into a couple different forms. We are chemically combining it with the oxygen to make ash, carbon dioxide, and water vapor. 3 new substances, which means the chemical change. This diagram here talks about all the different elements of the law of conservation. As we already alluded to, it's also known as the law of matter conservation. It cannot be created nor destroyed. Now the important thing to remember with this is it has to be the mass of a closed system. Now a closed system would be one in which we do not allow any gases to be released. So think about a vacuum setup. This fourth spoke down here simply dictates that any chemical process in a closed system, the mass of the reactants must equal the mass of the products. And we can also elude this one with a physical law. It's about as close to a physical law as possible in terms of the when we're talking about ice melting and that type of thing. We're also talking about conserving that energy. When ice melts, you get the same amount of liquid mass as you had as solid ice. This here is just a sample problem to try and grasp the idea behind what's going on. The key part here is figuring out what the reactants are and what the products are, keeping in mind that reactants are what's found on the left side of the arrow before the reaction, and the products are on the right side of the arrow or after the reaction. So the problem reads 15 grams of iron combines with 32 grams of sulfur to form how many grams of iron 2 sulfide? So before any type of reaction takes place, you have to ask yourself, what are the components that are present? Iron is present and sulfur is present. So we could roughly create an equation that iron plus sulfur makes or equals iron 2 sulfide. Now you may not know the symbols that are associated with it, but the words will do just fine for this equation, for this purpose. We then take the numbers associated with each amount, 15 grams of iron and 32 grams of sulfur, and we plug those numbers in underneath the equation. 15 grams of iron and 32 grams of sulfur. Now the problem becomes very, very simple. According to Lavoisier's law, we can neither create nor destroy matter, which includes mass. If we can't create or destroy it, it means that since these two things here combine together to form this third compound, they must add together to form a grand total of 47 grams. 47 grams of our compound will form as a result of 15 grams of iron combining with 32 grams of sulfur. That's all we have for the law of conservation. A pretty easy math concept, and one I'm sure you will not mind seeing on a test.